Kristen for influencing me. I hope he's not in the chat right now.
For getting you to hate all game engines.
Specific. Oh, you're right. I guess I am being really negative about game engines in general. You know what? Everything that's not Unreal or Unity can get lost. Unity can get lost. Actually, I have some choice words about Unity.
Yeah, I'm pretty sure I'm done with Unity.
That's fair.
I don't know if I'm going to come back unless it's job related. Especially since I mostly work in 2D.
Yeah, Unity's my favorite. I was gonna say I've seen games like what I would do for that, and it's probably unnecessary for a game like what you're doing, but you can do the curve for the shader so that it's actually flat, but it looks like a sphere. The only hard part with that is the stitching of the two seams, but make the planet really big. What's his name? I think Sebastian. One of the 3 tech artist YouTubers did that, but like 3D for how Animal Crossing Wild World, and one of the other ones does it. Well, it doesn't actually loop, but it's complete. It's just flat 3D, but it looks round. I don't know. It's really cool.
I want to go through and just like do every Sebastian, like just implement it.
And you can.
That's what
Yeah.
the cloth simulation I did, that was from a Sebastian Lee video.
I really want to get back into.
That cloth sim is amazing, by the way. Please find an excuse to use that in the game. It's like a mini game or something. You just have to like cut it.
Did you play it? I added like cutting and like node locking and shit.
I'm
gonna add some like physics so you can tap the cloth and it like wiggles around.
Let's put it on the 3DS.
So my lesson plan did not save anyways. So we're just gonna freestyle this entire thing.
I believe in you. I believe in you and the 3 people who downloaded the Pico-8 link.
I would have, but my computer doesn't.
So sorry about that, by the way.
I still need to figure out what the legal means of repair for that.
Maybe because your laptop might be unlocked. The only time I've had to do something like that is I tried to get Lenovo to repair my broken VR headset, and they literally told me, not only will we not do that, but we won't give you the proprietary parts to do it yourself. So I just do it away. It's made me. I'm not one of those right to repair freaks.
Right to repair is important. Nobody has.
Best of luck to getting your game.
I do most of my game dev on my desktop. It's just the real problem with the laptop is that's what I do most of my schools. Like I have until I get that fixed, I just cannot attend my assembly lectures because they're online. But I have a class 10 minutes before that starts, so I can't get to my desktop and talk. Luckily, they're all like he doesn't take attendance and they're recorded, so I can just watch them later. But it's still
maybe you can. No. I'm casually watching Harper over here with quite literally 3 Pico-8s running at once. Well, I'm beginning to understand why I don't get it.
I have my original one here. I have my half-finished lesson plan one here with no lesson plan with it. And then the one we're going to be working on. So it's going to be fun.
Oh, I throw Pico-8 on my laptop. You don't have any announcements. You got it from here.
Oh, shit. Zoom, can you hear me?
Yes, sir.
Zoom, hello, hello.
I was really confused. I was like, wait, are we supposed to be?
All right, dope. Hey everyone. So today we're going to be doing a Pico-8 workshop if you haven't already heard. So I'll be going through the basics of Pico-8, how to create this little shooter that I think I posted in Discord. You can take a look at it. It's just a simple turret. You can shoot bullets at this red ball. If we get far long enough, then I'll add some more things like score and whatnot. But otherwise, who all downloaded Pico-8? Who has a license? 2, 3, 4, 5. All right, 6 people. That's good. And who all has downloaded a license and has no coding experience? That is very helpful to me. All right. I'm going to put on some tunes as we work here, just that I can't hear over my thoughts. No, there is not. That'll do it. All right, so you should have a folder with Pico-8 in it, and it should have a few other things in it as well. Should look like this, except minus the batch file. You're just gonna want to launch it, and we can get started. Of course, it kicks off my spot. So the first thing you want to do is just hit escape, and instantly you're in the code editor. As you can see, it's very pixelated. And you're welcome to like interrupt me at any point to ask questions if you get lost or if I screwed something up and it's not working on your computer. We can hit escape, takes you straight into the editor, and we can go ahead and start typing code. First thing we're going to want to do is give our cart, which is like the type of game that we're making, a title and an author name. And this will just be for later. Yeah. Yeah, I'll pull it up some. All right. Yeah, it uses a fork of Lua. Lua is a very simple scripting language, very powerful as well. It's kind of object oriented, but kind of not at the same time, and I'll explain that later. It's a fork of Lua because it has some features that Lua doesn't have. So it's like, it's a version of Lua with just a few extra things. I don't know if you all know Lua. There's probably most of you know Java and maybe C# because of Unity. But anyways, we want to give this a name. So we'll call it, since we're creating like a turret thing, we'll call it turret shooter. And you're just going to want to put your name. This is for later. When you export the cart, it'll have a little title image, and it'll display both of these things for you. Now, I did lose like all of my lesson plans, so we're just going to be kind of winging this. So do let me know if I do something wrong. Let's see here. All right. To start off, we're going to jump into creating a new tab, which you can do right at the top here. I guess you can just full screen this. Well, I don't know if you Zoom, can you see this when I full screen it? Yes, okay, good. And on this tab, we're going to create a comment, draw, and a new function. And in Lua, you just create a function by typing function, simple enough. And we're gonna call this draw with an underscore in front of it. What this does is Pico-8 is going to call this frame every, well, or it's going to call this function every frame and draw something. There's also another function called update. Keyboard is not tactile enough. And this function is going to call every frame, and the draw function is going to call after that. So we want to put everything, all of our frame drawing, anything we put in here, like we can draw a circle at 64, 64, the radius of 8, and the color to 7. So this is a function we can call for drawing a circle. You put in the X coordinate, you put in the Y coordinate, you put in the radius, and you put in the color. And if you go over to the sprites tab here, which we're not going to be using unless we get far enough, you can see all of the colors are displayed here, and they're displayed from 0 to 15. So when we put in 7, that's white. If we put in 6, that's gray. If we put in 5, that's dark gray. If we put in 4, brown, and so on and so forth. If we hit Control R, which runs our game, you can see there's a circle right in the middle of the screen with a radius of 8 and the color 7, which is white. So we use this for drawing things because it draws every frame, and it draws them after update, because update is where we want all of our frame code for controlling objects and whatnot. But we don't need update right now, and we actually don't need this circle function. Instead, we want to start drawing our turret. So to do that, we're going to want to first clear the screen. There's a function really useful for that called CLS. And if you comment out the function, you can see we get all this. It says Pico-8, tells you the version, tells you the copyright, type help for help. But if you use CLS and hit Control Run, you can see that it clears the whole screen to black. If you wanted it to be a different color, you could put in one of the numbers. 4, we get brown. 8, we get red, and so on and so forth. Now, we start drawing our turret. And we're going to create a separate function for this to keep it a little cleaner, that Pico-8 doesn't draw or call, because every frame, Pico-8 basically says, I want draw and update to go and do what is nested in the function, but we're going to create our own function outside of that. I'm going to call it draw turret. It's just a comment. We're calling the function here, and we're going to put it down here. All right. So every frame, this is going to be called because it's in the draw function, and we can go into the draw function and start drawing our turret. So we'll start with the base. I should probably have the other, let's see here. I'll pull up the other Pico-8 real quick so you can see what we're working towards, or the other, the game that I've already finished. this is what our game's gonna look like when it's done. As you may have seen posted to the Discord. And right now we're gonna draw that bottom bit with the little turret. We're gonna start working on that, and the line at the bottom, which indicates if the ball has passed the red death orb and the game is over. So to start drawing that, we're gonna want to draw that line first. I'll pull this up to full screen again. The line function takes 4 positions. It takes your x1 position, your y1 position, your x2 position, and your y2 position. So the x and y starting positions of the line and the ending positions of the line. And then it takes a color. So since the screen on a Pico-8 console or fantasy console is 128 pixels wide, we want to put this line at starting at 0. That's the first x coordinate. We're going to put the y coordinate just at 120 right now. We're going to put the second x coordinate at 127. And we're putting it at 0 and 127 because it starts at 0. Like, it's kind of weird because the rest of, like, Lua, most indices start at 1, unlike Java, C#, most programs, because Lua is weird and wants to be special. But for some reason, they also chose to start the coordinates at 0, even though Lua starts at 1. And they decided not to change the starting indice to 1. But anyway, Lua is 0 by 128, right? So we've got our x and y coordinates. We'll put the second y coordinate in here. And this is just going to draw it across the screen at the bottom, like so. As you can see, x and y coordinates start at the top left of the screen and they go down to the bottom. So when we type in 120 for y, it's going to go all the way down to the bottom there. And we can draw it at the bottom of the screen. Now we're going to have to draw a lot of things at 120. So we're going to soft code this in real quick. Go back to our first tab. I'm going to create a little comment here called tweakables. That's what I like to call my variables that I tweak with. We're gonna call this base y, and we're gonna equal it to actually 118 because that's what I used in my other game, and I think that's to make room for the circle. Now, if we go back to this screen, we could throw base y in both y coordinates, and it's in the same position, just about. If you want to go ahead and save your game before we move on, you can hit escape and just type in save turret or whatever you want the name to be, and it will save it somewhere in your Pico-8 directory, wherever you have it saved. Or actually, I think it saves it somewhere under users, but I can get into that later. You can find it pretty easily just by looking it up, or I think there's a help option in the Pico-8 console menu. All right. So we've got a line. That's the line we don't want the death orb to pass and kill us with. So moving on from that, we're going to start creating the actual base of our turret. There's 2 more functions that I can introduce here. The first one is circfill. It's just a circle that's filled. It's pretty explanatory. We're going to put the x position at 64, middle of the screen. We're going to put the y position at base y, right on top of that line that we just created. So the radius here to 8 and color to 0. The color 0 is black, so we can't actually see any progress here other than it drawing over the line. But that's so that we can create another circle. Same positions, same size, but it's not filled in. We're going to set that to gray. So now we have a little gray box down here for a turret, a gray circle rather. So we have a base for a turret, and we want to start drawing the actual turret, the gun, the barrel, the thing we can shoot things with. I'm gonna start with a comment, draw. Create a line. Because if you look at our other example, you see we have our little orange line, which moves around, and that's what we're going to create right now. And we're going to put this at the same starting positions as both the circles. So 64 base y, because base y is where we draw that line on the y-axis. Base y. It's the y coordinate. I know you came in late. But it's the y coordinate that we're drawing our line on at the bottom of the screen. Let's see. For now, we're just going to put the second x and y coordinates to 64 and 110. And I believe we just count here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is the color, is for the color orange. So now we have a little line here. But we want to get that line moving. Just a quick recap: x position, y position, second x position, second y position, and the color. Control R. So we're going to want to control the second position for this line. Just like we can in here. You see it rotates around our original base for the turret. And so to control that, we want to create new variables in our main thing here. I'll put this under game variables. We're going to create 2 new variables. Actually, we're going to go ahead and create 3 to make it easier. We call one of them x2. We'll set that to 64 for now. One of them y2. We'll set that to 110. We're going to take those variables, put them back over here, x2 and y2. You can see it's exactly where it was before. But we need to get this moving. So how do I get it moving? We're going to actually also add a variable called rot for rotation. We're going to set this to 0.25 because that's going to be about halfway in the middle where it is now. But 0 would be facing to the right. 2.5 would be facing the left because of how we're going to do this math here. So to control this, we need to go ahead and create a new tab. We call this tab update. If you can notice, you scroll over the tabs, it's going to say the first thing you commented in the tab. So it's just useful to track back to basically a title. And we create the update function that we talked about earlier. Function update. And as mentioned before, the update function just says whatever nested in it does whatever is nested in the function every frame. Pico-8 calls it, tells it, hey, do this. It's like, okay, I'll do it. And we move on. But what we're going to put in our update function is the math for updating the barrel coordinates. So we're going to create a little comment here, update processes, and we're going to add a new function called update barrel. We put this function down here. The reason we're just not nesting it in the function update is because we want to keep it clean. We want to keep it pretty. This is clearly Pico-8 is very hard to read. It's a bunch of pixels. So it's, the more pretty you can keep it, the more separate you can make your code, the easier it's going to be to read, and the less you'll hate yourself when you come back to it later. All right. In our update barrel function, the first thing we want to do is set those x2 and y2 variables that we made later for controlling the end of our barrel on our turret. So we're going to calculate forwards. X2 is equal to, or I'll explain this in a second. All right, so if you set your x2 and your y2 variables here to these cosine and sine functions, basically what it's going to let you do is rotate your barrel around the base of your turret. Now, I can't tell you exactly how this works because I don't really understand cosine and sine myself, but they do magic for rotations and orbits. So that's what I can say. When you throw in rotation to cosine, it gives you the x position of where that rotation would be. And when you throw rotation into sine, it gives you the y like coordinate of where the rotation would be in respects to the turret. So we add 64 because it's the middle of the screen. It's going to show up right in the middle. We add base y because that's where we want it to start, the same as 64, the turret center. And we multiply it by 16 for length. So if we were to get rid of times 16, we just have this little minute turret barrel, and that's no fun. So we want it to be packing. Thank you, Logan. So we have our turret barrel, but our barrel doesn't move. To get that moving, we want some input. Input is very simple in Pico-8. Create a new comment here for left input. And we create a quick if statement. That detects what button we're hitting. And that's what this command button right here does, is you can use it to access any of the keys on your keyboard. And then to put in the button that you want, well, in Pico-8, we only really have a few buttons that we use. We use the arrow keys and X and Y. And there's limited buttons because it's supposed to be a retro console and because the creator wanted it to be accessible on any device. So you can play all the games on a Game Boy that has a Pico-8 port on it. Play all the games on your phone with just like a few buttons that you can tap. So for this, we're gonna hit the shift button and hit L on our keyboard. And it's gonna give us a little icon that resembles the left arrow key. We do the same thing for our right input. And hit Shift R, and it will also give us a little icon that represents our right arrow key. And here, we just go ahead and take the rotation variable that we made earlier. And set it to rotation plus 0.01. We want it to be a little bit of a small number because we're working with small values and units. And in our right input, we'll put rotation is equal to rotation minus 0.01. You can also do plus equal or minus equal because this fork of Lua allows it. I'm just typing this way because for some reason the main fork of Lua doesn't allow plus equal and minus equal. You have to type it all out. And since I've been using Lua in other applications, I've been practicing that. And also, if you don't know what it does, it's just simpler and makes more sense to type it out like this. And now our barrel is controllable and revolves around the turret using the sine and cosine functions we used earlier. Except we don't want it to go past this line here. So real quick, we're going to add a tolerance to our if statements. We do that by adding and. Condition is bigger than 0. So 0 is going to be the position we don't really want it to go past, and the 0.05 is going to be a bit more of an extra tolerance. Actually, I think no, I wrote that wrong. It's less than. There we go. So now if we take our barrel, it can't get past this point because we don't want it doing full revolutions, so that after our enemies have reached past this line, we can't like shoot them anymore. We can do the same thing for our input down here, our rotation. The reason I'm just not doing the math here and I'm adding and subtracting them later, or adding them and subtracting these numbers is so that when we come back later, we know what these numbers mean, because I'm hard coding the values, but I still want us to know what they mean. So 0.5 represents the bottom left of our rotation, and 0 represents the right of our rotation. I can kind of just look at that and understand that. So then we add the tolerance, add or subtract the tolerance, and it lets us it keeps us from going past a certain point, like so. All right. So now we want to be able to shoot stuff. For the key press, for shooting things, we're going to do Shift X, and that's going to give us the X key. And we're going to come back to this later, so we can actually get the code somewhere else, and we can spawn our bullets. So we're going to go back to, all right, any questions so far? Anyone lost? All right. Logan?
Know this off the top of your head, but you mentioned that there was like a pretty small number of like control inputs. Do you know how many there are?
Well, there should be only 6, unless you tap some memory, and then you can use any keyboard controls you want. But we're not going to tap memory because that's not a fun thing to do when learning Pico-8. We're gonna go back to our main tab here, or our main file folder, whatever you want to call it. And we're gonna create a new function for spawning the bullet. This is where we get into object-oriented programming in a programming language without object-oriented programming. And how this is done is through these things called tables. In most programming languages, you have objects, classes, lists, dictionaries. In Lua, you just have tables, and that's it. And I'll show in a second how this can be done and achieved. We're going to create a new table right here. And a table is just going to be set in a normal variable like all of our other variables, because in Lua you don't have to initialize with types or anything, so there's no like real idea of like integers or strings or anything. You don't really have to worry about that unless you're casting variables, which you don't have to do often. We are going to make this local, and making this variable local allows it to not be accessed anywhere outside of this function. Everything else is global. We can access X2, Y2, rotation from anywhere we please inside Pico-8, this Pico-8 program. And When we said it's local, it can be only accessed within its nest. So we can only access bullet under function spawn bullet. We can't use that variable anywhere else. And to create a table, it's just going to be the squiggly brackets left and right. And then we can put items inside of the table. And for a bullet, since we're using this in an object-oriented context, we're going to give an X position. We're going to leave it empty for now. Let me come back to that. We want to give it a Y position. We're going to give it a DX position, which is our delta X, which means it's basically our velocity, and a DY position, so our velocity for our Y variable. We're going to set the start position for the bullet to X2, because that's where the end of our barrel is. We'll set the start position for Y to Y2, also where the end of our barrel is. And we're going to create two new arguments for our function called velocity X and velocity Y. And we're going to set our dx and dy to that. That's where things get a little weird with Lua, because a table can be fully used as like an object. So we can actually create functions inside of our table to use later. So right over here, we're going to create a draw function. We create a new variable inside the table called draw, equal it to a function. Basically, now we have a working function inside of our table that we can call later. When doing this, you always have to put self inside the arguments. And what that does is just so you can pass a reference to it when you're actually calling it. And that's done through a colon operator, but I'll explain that later as well. So inside of our draw function, we're going to draw a little circle that represents our bullet. I'm also going to expand these parameters out so we can see what we're doing better. So you can see I'm using self here before everything because I need to access all of the variables inside of here. And you can't do that without passing self through the function. If any of you use Python, it's done the same way in that. You have to initialize an argument in the parameter that represents itself. So we're setting the X coordinate of the circle, the Y coordinate, the radius, and the color. We're going to set to 7 because that is white. And then we want to be able to go through every object in the game and draw them. So we're going to add this to a table called objects, or OBJS as shorthand. I haven't created the table yet, told you just a hot second. This add function that I'm doing right here, it basically just adds it to the table. That's all it does. So you list the table that you're adding the variable to, and it takes the variable and plops it in the table. And real quick up here, I'm going to create that table. OBJS is equal to squiggly brackets. And now we've added our bullet to an object list that we can access later. But we want to see our bullets. We still have an unclosed bracket somewhere. This is fun. 20. Huh? I don't think so. Hold on, let me check my other code that does work. Oh, here's the problem. I put our add table function inside of our table. Can't do that. All right, yeah, there we go. I'll clear it up. Okay, so you still can't see our bullet. We haven't spawned anything yet. Because there's a little work to be done before we can actually draw these objects to the screen. Real quick, we're gonna go back to the input where we shoot our bullet, and we're just gonna type spawn bullet. I will just put in 1 and 1 for now. Actually, no, 0 and 0. This is going to be our velocity, but we don't want to deal with that right now because we want to see our bullets actually being drawn to the screen. We'll calculate our velocity later. For now, though, we need to go back up to our draw tab, and under our draw function, which is called by Pico-8, we need to loop through all objects in the table and draw them. So we loop through objects for obj and all objs do this function right here, all, it basically just creates an iterator for you that goes through every object in the table that's listed. You don't know what an iterator is? It basically is just some code that says, I want to go through this list one item at a time. And then we can do this. That should work. Yep. Okay. In your loop, just try obj : draw. And this colon right here is what passes the value obj to the function that's nested inside of obj, which we talked about earlier. Right here, that's what we have the self here for. The colon operator gives it this variable called self. It's just passing itself to itself. It's a little convoluted and probably doesn't need to work that way, but it works. So obj : draw, and then if we start our game, we hit X, our bullets are drawing. They have no velocity right now, but they do draw to the screen. We're also gonna, I forgot to change, if we go back down to our shooting input, change this to button P. Button P activates every time you click it instead of if you hold it down. We don't want our turret to go off like a machine gun. All right. So we got to give our bullets some velocity. To do that, we just do a pretty simple 2 sets of equations here. We're going to use local again for our variables because that keeps it inside of this if statement here. We don't want it to leave this if statement because we don't want it called anywhere else. We'll call this velocity x. Let's see what I did here. We'll equal this to -4. That's where the middle of the screen is, minus x2. That's our global variable that says where the ending x position of the barrel is. And we're going to multiply this. Well, we're going to multiply this by a new variable called speed mod. We want to go back up here to tweakables, add a variable called speed mod. We're going to set that to 0.25. And local velocity y is equal to negative. Yeah, 0.25. Base y, so that's where our turret is located at, minus y2 times speed mod. And this math basically just gets the direction that the bullet is in. But because I didn't want to go into how to normalize vectors right now, we're just going to scale it down by this speed mod, which we just set to 0.25. We're going to pass this in through our spawn bullet, or spawn bullet. Cx, velocity y. And now it still doesn't work. Oh, because I haven't even gotten into updating the object positions yet. Right, okay. So this is very similar. What we're gonna have to do here is very similar to how we drew all of our objects. We actually go ahead and Control C this entire thing that says loop through objects. We're gonna take it over to our update tab. We're gonna go into our update function. We're gonna comment update objects. Or just loop through objects. Yeah, we're gonna copy that loop over, and we're gonna change out draw with UPD, short for update, which we haven't created that function yet. But if we go back, we go back over here to our table. We can go ahead and create a new function under it called update, or UPD for short. This should be pretty fast. We can see our bullets moving pretty quickly. We're just going to set self.x is equal to self.x plus dx, and self.y is equal to self.y plus dy. And all that is doing is adding our velocity to our positions so that we can get another error. What am I doing wrong this time? To perform arithmetic on global dx and nil value. Oh, because we forgot to add self.dx and self.dy. There we go. Value of the turret. And you can shoot things.
Wait, which one you did again?
I put it inside of the bullet table that we created earlier when spawning the bullet.
No.
Oh, right. Yeah.
The update.
Right here.
Oh.
We replaced draw with UPD because we're calling the function that we're passing our value to. Does look like we're running out of time here, but I'm gonna see what else I can fit in. Luckily, I lost the rest of my lesson plan anyways. All right, something I probably should have explained earlier. There is one more function that Pico-8 calls other than update and draw, and it is the initialization function. Hopefully, all these functions, if you've worked with game dev stuff before, should be pretty familiar. They have them in Unity, they have them in Godot. Every major engine that I've worked with uses them. But this is just for, it's called at the beginning of each game. So you can set some variables, do some simple math that you need to use for later. Type of function init. Stands for initialization. Inside of that, and we're going to spawn a death orb. And we want everything in the death orb to be very similar to what we have in the bullet that we spawned. So we're going to set an X position. We're going to put this at 64 for now. Set a Y position. Put this at 16 for now. Dx is equal to 0. Dy is equal to. Let's see what I said to do before. Set it to 0.5. And then if we go ahead and create a draw function, radius of 7, color 8, that's red. And then we also create an update function. Just copy everything from this function right here. We should see, oops. And we add it to the table. You can see we have a little death orb here that scrolls down the screen. And we can't shoot it or anything yet, but that's that would be our enemy. Go back over here. As far as we've gotten, created the turret that can shoot things, created the barrel, created the death orb. We have not looked into collisions. That's actually pretty simple. I could probably post the code about that later. But I guess, well, yeah, we got 10 minutes. I guess we can see what we can get into here. All right, is everyone following? I'm getting groans, but
Yes, but actually, no. Where did you add the death orb to the table?
all right.
Is there, I guess both of them are gonna fall, just because it's on a net? Like, did you call it there on your other one, is what I'm asking, or?
Oh, it's so we've added the death orb table to the objects table, and in our draw we call all objects.
Okay.
Yeah, so it goes through every item in objects and it calls the functions inside of it. And since we've set a draw function and an update function in both our bullets and our death orb, it will call both of them and be happy. I'll see if we can get into the collisions right now. We're gonna kind of speed run this, but go ahead and create a new tab called miscellaneous. I'm gonna create a collision function. All right, for our collision function, one thing we're gonna have to do is go back into our death orb table and our spawn bullet table and add a radius to both of them. We're gonna set the radius to the radiuses that are inside of the circle functions. So here we'll set it to 7, add that comma, and then inside of our circle function, set it to self.radius. Yeah. We're setting it to oh wait, yeah, you're right. I'm tripping. That's my bad. Radius is equal to 1. Self.radius. There we go. All right. And then do the same thing up here, except this time it actually is 7. Self.radius. And set the radius to 7. Should all still work accordingly. But we can use this value for the radius to calculate our collisions. So over in our collision tab or miscellaneous tab with our collision function.
Was it 7 for the?
Yeah, it's go back to the code here. For the depth orb, radius is 7, and make sure to set the radius inside of the circle function to self.radius so that it calls that. Let's see here. All right. So the first thing we have to do for collision data is to get the distance in between the two objects, being bullets and the death orb. To get the distance, x distance is equal to obj1. We're going to pass both the objects through the function here by our arguments. So obj1.x minus obj2.x. Local y distance is equal to obj1.y minus obj2.y. Distance. Right here, we're going to use the Pythagorean Theorem to get the distance between the two, because we have the x distance here, which is one side of the triangle, y distance, another side of the top triangle, and what's in between is the hypotenuse. So to get that, local distance is equal to square root of x distance to 2 and y distance the exponent of 2. And to check for collision, we're going to return the value, which we haven't done yet, but all of you know programming, so you should understand it. Distance minus obj1 dot radius minus obj2 dot radius is less than 2, 0. What we're doing right here is we're getting the distance between the two. And then we're subtracting the radius of the two because the distance is only from the centers. And we're checking if that distance is less than 0, because if it is less than 0, that means they're touching. That means the distance is 0. That means the distance is both of their radius combined, but we've subtracted the radiuses, so it comes down to 0, and we can return a true or false Boolean that checks for the collision. Back in our update function, make sure there's no problems here. All right. What we have to do is we have to go back to our main tab and add a new object table called bullets, so we can loop through just the bullets and check their collision with the death orb. Then we have to scroll down to spawn bullet and make sure that on top of adding it to the object table, we also add it to the bullets table. We go back to update for bullets. Do the same thing we did for looping through objects. The bullet in all bullets. We're going to check for collision. Local collision is equal to collision. Use the function we just created that checks collisions for circles. We do bullet, and we're going to pass in death orb because that's a global variable. If the collision is true, then we can tell it to delete our death orb from the object table. Oh, that did not work. Actually, you know what I did? I didn't delete it. I set. So why is it a -16? Make sure my collision function is right here. Distance minus -1 to the radius minus -2 to that radius. So that's what we consider. Distance in the square root. Oh. Square root does not use a comma. And I'm going to add those two. So if they collide, we're going to set the death orb to a y position of -16. We're going to delete our bullet from the bullet table. Oh, no, we're going to delete our bullet from the objects table and the bullet table. That's my bad. I totally did this wrong. That's backwards. There you have it. Now you can shoot your death orb. And I would add a game over screen, but our time is up. If anyone has any questions, just ask me. You can even come up here if you're curious about any of the code or how it works. I'll let you know. What's up?
The number from bottom right corner, are you limited to 8,192 different words or what?
Yeah, it's a token count. Pico-8 has a very limited memory. For the same reason that there's a limited amount of keyboard characters that it can use. We want it, like the developer wants it to run on basically anything. So it can run on a Raspberry Pi, it can run on a Game Boy. There's been Game Boy hacks.
TI-84.
Can probably run on a TI-84, smart fridge, whatever.
Wasn't that like a birth, a pregnancy tester? Someone ran doing it for
I believe so.
Okay, that makes sense.
Yeah.
I was gonna say, like, is someone really
Well,
able to run Doom?
They still put a video player inside the pregnancy test,
that's
didn't
still
they?
pretty good.
Yeah. All right. Thanks for coming. Thank you.
Yeah, I'll see you guys. See you. Thanks everyone for coming out. Anyone who requested the Pico-8 licenses.
Peace, Zoom.
I might be with one after this. I requested mine. I was just curious, so I didn't know it was. How do you get out?
Will this, if I just end the meeting, will it save the recording? Okay.
Famous last.
Well, that.